Introducing NammaAUTOSAR. Namma means ours in most of the South Indian language. The picture that you see below is the graphical user interface of the project. The Before we go to the details, I would like to share some information on why and how it started. So by June 2021, the need for better learning of AUTOSAR uh, arised. So by August 2022, um, I started writing an operating system with a simple graphical user interface. Today, it has come to a first stage of AUTOSAR development environment. Hence, I thought I should publish this as a video and present it to all. So, where can you find it? And yeah, simply go to github.com, search NammaAUTOSAR. You should get these two links and click the first one. I'll be demonstrating these in a few minutes. And yeah, so how do you get start? How do you start using it or exploring it? And yes, you can. Some information are available in the README file. I would like to thank Raghuram, who's helping me to create the README pages. Yes, we will be adding more details to the project so that it should help everyone to uh, learn it or understand it. So let us go to the github.com. So just type github.com and there's a search window here. Just type NammaAUTOSAR. Yes, you got these two links. Click on the first link. Scroll down, you will be able to see the documentation. So most of that, whatever I told is here. And yeah, here is the getting started pages. Just follow these instructions. Let us know if there are any issues. And this should work straight away. And yes, here is the development setup that I used. Maybe I will click open it and then start speaking it. So you see the green color thing in the center is the Raspberry Pi Pico, and I bought Maker Pico Maker Pi Pico board from Cytron. So mainly I hate using breadboard, and because many times I don't want to spend time in connecting and reconnecting, and it comes with some kind of groove connector and most of the jumper wire connection options available. So I thought this would be a good starting point to work with. So I went with this baseboard as well. And currently I'm using Groove 1, 2, and 3. So if you see here, I'm connecting to the Ethernet encoder. You can see this picture from Groove 1 and 2. And Groove 3, I'm using it for connecting to the USB to UART cable. So that's about the hardware setup. And yeah, so how to pull and how to clone from a fresh start, everything is available here. So I will be demonstrating them one by one. So I will not be cloning because the cloning is done for the better sake of using the time. I will directly go here, the OSS and you are minus okay. So make sure you are uh, in the clone repository, and here you should see these are the folders. So config, docs, submodules, tools, and the config folders are where you will find all the air XML and the oil configuration files. Doc is where currently there is not much, but we will be adding more documentation stuff here. And submodules are the AUTOSAR submodules, and yeah, I will touch on that a little later. Tools is where I think you should listen now. Under tools, you have the root or the main entry script, Python script. So that's what I'm going to invoke. So if you install all the software that I have told previously, it should be straightforward. So just Python tools and AUTOSAR UI. Okay, so So here is the GUI. And for the first time, you will have to import ARXML file. So don't go with new because uh, the project is not ready to support new configuration from scratch. So better for better purpose, you click on this one. Even don't even choose the other ARXML file. So Raspberry Pi Pico, because that's being the one that is tested. Here you got the graphical user interface, and this was kind of got inspired by. Let me show you the AUTOSAR layered architecture. Yeah. So the graphical user interface of NammaAUTOSAR is inspired by this picture. So this is something that you might find it in AUTOSAR specification. So now you will notice that not all those blocks uh, are not there in this graphical user interface because yes, I'm slowly building those blocks as one by one. And the interesting part here is every block here, if you click, you will get something like this. So I just now clicked the microcontroller block and I have got the options to select one of the board that is supported. Right now only Raspberry Pi is tested. Don't try testing on some other pieces. And here there's only one SoC variant supported. Anything that will be coming in the future will be added. And yes, and if you click on the OS, you will get the OS configuration. People who are familiar with AUTOSAR configurator tool will be familiar with most of these tabs, and you will see that OS alarm configuration. I've configured 4 alarms and different types of configuration, and I also given arguments to select the OS. For example, you want to change the third type from alarm callback, where you see the edit box here, and you want to change that to uh, set event. Yes, the moment you select the action type, the argument one and argument two changes naturally. So this UI is something it would reconfigure accordingly to based on what you select as how you wanted to trigger. So if you select activate task, it will list all the tasks that are available there. So if you go to the task bar and if you want to add one more task and say task demo, and then come here and select here. Oh, okay, that's not happening. Let me say this one. Now you got it. So task demo is there. So some minor tuning is still needed, but this is just a demo of how to configure the OS. And yeah, likewise, you have several blocks, and application is a special case I'll be touching up a little later. But you can see Lin is being developed, but Spy is pretty complete. I've configured one Spy, and that Spy is basically configured for for this purpose. So if you see here, I'm using Spy to connect to the encoder 28K60 Ethernet encoder. So there is one Spy I have used, and therefore, if you go back, you will see that I have used one sequence pointing to one job and pointing to one channel, and the channel configuration will speak everything, and the details are available here. Similarly, yes, you will also see the port configuration. So if you go to port, yes, I'm currently using say 7 ports. Out of them, three of them are SPI, and even the chip select. I wanted to select SPI, but that was not working, so I made it to DIO, and yes, that is used for the chip select will be operated as a chip select to support the encoder. And apart from that, 2 LIN are configured for the LIN development, which is happening in parallel by one of our contributor. And yeah, one DIO is for the LED light, port number 25. So yes, this is a overview. If you click on different boxes here, you will get it. Now it is time for me to click on the application. bar on top. So app is a special case because the BSWs are tightly coupled, so you can clone all of them together. Therefore, I put them as Git submodules. But app is not the case. Different people, different users may have different set of apps. So I kind of couple them into a, application config. And if you see the VS Code, and if you go to submodules, anyway, as I told, I will be covering the details later. Under submodules, you will also see application.json. So yes, all the applications will be kind of say configured. All the configuration will be stored as a JSON file, and you will see all the applications information here. So you can add applications, but make sure that you install or you give only the Git path here. Otherwise, it won't consider or it will ignore. Okay, so now if you update it, okay, so every time you do something, and if somebody else is working in parallel, please update them as often as possible. So in the background, what it does is it does a git pull, and if it's already up to date, you will get it's already up to date. And yeah, the UI is so poor. I'll be adding more UI so that user need not look into the command line to know if an application is up to date or not. So I'll be providing that information in the future releases. So yes, going back to the view here, so that's about app. And say, for example, like for some reason, I'm just adding a demo.git, assuming the demo.git URL is like this. And if you close it, you will see the demo.git here. And all the app configuration I wanted to give, but currently, due to lack of time, these are empty dialog boxes that may come, but this will be added later. So for now, I will remove this and then close it. Yes, the demo application went away. So that's about the applications. But for now, so yes, assume you have configured everything correctly as you have seen in the earlier part of the video, and now you wanted to build it. So yes, close the application, do the saving, and yeah, I forgot to mention about the code generation part. So once you are done with say you configured the Ethernet, and you want to change the MAC address of this, say MAC address or anything you want to change, you changed it. Either you can select save config here so that it saves all the work. It also generates code. Okay, so it save button will trigger both saving as well as exporting to ARXML, also to generate code. But you can also use the generate code options to generate the code. So yeah, here made some attempt to provide some usable UI. Yes, finally you will get the code generated successfully as a note. Then it's time for you to close the window. Finally, yes. So you see some logs here, and all you need to do is make. So if you have a multi-core laptop, based on the number of cores you have, you can give as a minus the option. So for me, I have I don't know exactly. I think 16 core, 16 virtual core, and 8 actual core. So let me give 16, and you will see the make happens in parallel, and the whole make will be done in less than a minute, and the whole thing is now ready for testing. So how do I test it? Yes, I have connected my Raspberry Pi target, and you will not see it now. Now, within few minutes, I will be showing in a video, taking from my cameras. Okay, so yes, I'm using J-Link debugger, and I'm also using Segar Embedded Studio, and yes, uh, I ensure that I power them. Yeah, give me a second. I power the target, and I already flashed it. You may not see. Okay, so it is flashing it again. All you need to do is just say go. So before saying go, I wanted to ensure that the putty is there. So I want to connect to the putty since I have the J debug cable connected, as I showed you earlier. And I also wanted to show you Wireshark thing. So Wireshark to show what what am I doing? Give me a second. So Ethernet 7 is what I have connected the Raspberry Pi Pico to, and you will not see that messages are going always from my HP laptop to check for ARP, and I have not started my NammaAUTOSAR OS yet. Still, the debugger is still holding it. But before that, I wanted to show you what my test application does, so that you will be able to understand it. So here is my test application, and Mac5 test will be called from a task called a task A. Wait a second. So many, yeah, task A, and inside the task A I have a toggle bit. So now if you see the configuration, give me a second, I'll go back to my UI. Yes, I go here. Yeah, if you've already opened the previously opened ARXML, it will list here, and go to OS, and I will show you the task A. Task A is triggered by alarm called wake task A. The periodicity is 500 millisecond. So in my test application, I'm toggling it. Therefore, every 1 second, I'll be sending a Mac, calling the Mac5 test. So Mac5 test basically reads some of the registers, and finally it sends an ARP packet, and also it will read the packet from sent from my PC. So inside ARP packet, yes, I'll be calling the function that I wrote, but yeah, the details, maybe I'm forming a raw packet as per IEEE 802.3 standards, and I'm sending the packet, and I'll be soon integrating lightweight IP, developed by Swedish Institute of Computer Science, I believe. So that will be that's in my next phase plan. So once, if that is integrated, I don't need to create these things. The stack will take care of all the protocol as per the Ethernet standards. So for now, yes, I'm going to run. You see, uh, Volkswagen BABA. I named it as Volkswagen Baba because I'm using the MAC address of Volkswagen while forming the frame address, and then I can change it to any of the MAC address that I can use it. But for now, for this demo, I will use it. So yeah, this is almost, we have reached the end of the demo, and before we end, maybe and going back to submodule, yes, submodules are broken down as application layer named as AL, EC abstraction layer. There is nothing there. MCAL layer, you see these many code, these many projects are added as submodules. RTE, nothing is there, and service layer only OS and ECVM. ECM is highly incomplete. OS is somewhat complete, and DIO, Ethernet. Ethernet is in the very starting phase, and port and SPA, and along with DIO are somewhat in a better state of completion, but lot more to do. And thank you for watching this video. So I would like to ask few people for help so that you can contribute it, but before that I would love to add that lightweight IP stack into it, and then we can discuss on how we can work together. Thank you for watching this video, and bye for now.